Good afternoon, everyone. Thank you for joining our webinar today. It's 2:02, so I think it's time to go. We got a bunch of people joining, which is really, really exciting to see because it is an exciting day for us here at Polar. As you may have seen the press release in the last few days, we were fortunate enough to be the winning bid and the ones to acquire the Axsus Solar division of Magna. For those of you who know or don't know, this is a division of a solar racking division that has been around since 2009, had done over 2.5 gigawatts worth of installs, and had come up with their own proprietary single axis tracker design, which we're happy to be the owners of, and now happy to present to you all as our latest offering from Polar Racking. So thank you for being here today. Next slide. So today with me, so just introduce myself. My name is Vishal. Lala. I'm the managing director of Polar Racking. I have a great team here with me today to, again, introduce you to this great product that we're offering from Polar Racking, which is our newest single axis tracker design. Today I have Rob Souliere, who's our Director of Operations and Construction, led the team at Axsus for many, many years. Again, was responsible for most of the 2.5 gigawatts worth of solar that they had deployed throughout the years. We have Jonathan Mizrachi, who is our Director of Sales in the US. And again, a veteran of the solar industry, based in New York. And happy to handle all your US inquiries. And we have Dikran Ghorghorian, who we refer to here as the godfather of the single axis tracker here at Polar Racking now. He was a longtime employee of Magna over 27 years, 5 of those in the solar division, and now the director of engineering here at Polar Racking. So through the four of us, we should say, we'll take you through our product offering and key benefits, and we'll be happy to answer your questions throughout the presentation, and then obviously definitely at the end. So just keep putting your questions in that chat, and we'll get to them as soon as possible, because we do want to make this as interesting and interactive as possible. So just to tell you a little bit about Polar Racking before we start and get into the tracker. Polar's a company that was founded in 2009. So this is our 13th year in business. We are a North American leader in the design, engineering, and manufacturing of PV mounting systems. Together, the combined team now has over 3 gigawatts worth of experience, on the commercial side, commercial, community solar, and utility scale solar side of the business. We do have a diverse portfolio of products, which includes carports, fixed ground mount, and single axis trackers. So here's a quick snapshot of our products. So we have PRU, which is our fixed ground mount product. Anything over a megawatt to gigawatts, you could say, we're set up to run and service and provide. PRUD is a product that we sell through distribution for your smaller scale solar farms, anything less than 1 megawatt. You generally going through distribution and buying one of these pre-kitted designs that come with a pre-stamped engineering package for racking, for foundation, and can be deployed pretty much anywhere in North America. We have our carports. Again, with carports, this is a really, really, really hot product for us. You may have caught some of our previous webinars. We offer all types of configurations, from L's to T's to Y's to long spans, and we do supply and install these products, as we do with we offer installation services on our fixed ground mount, our tracker, and our carports. And in the heart of this slide here today is the reason why we're here today, which is our single axis tracker, the Axsus Sol-X tracker, which we're going to tell you a lot more about. And again, as we go, please put those questions in the chat box so we can continue to, so you don't forget, and we can keep track of them, and we can answer them for you again throughout or at the end of the presentation. With that, I'll hand it over to Rob Souliere to start the presentation and take you through the key benefits and the agenda for today's presentation on the Axsus Sol-X tracker.
Thanks,
Powered by polar racking.
Yeah, thanks, Vishal.
Yeah.
Okay, today our agenda, we're going to introduce the Axsus Sol-X single axis tracker. Why choose the Axsus tracker? We'll go through its ease of assembly, site density, reduced grading, production in wind conditions, and lower foundation capex. We'll go through the design and specifications. We use the automotive philosophies implementing this tracker. A lot of us on the team have extensive automotive backgrounds, so we use those lessons learned and those techniques to design this tracker. And then we have product validation and testing of the tracker. Again, we used a lot of the automotive know-how and testing to test our tracker to automotive standards. Why select a tracker over a fixed tilt solution? I'm sure a lot of you know that a tracker typically has about 15 to 20% better production than a fixed tilt system. As you can see here in the graph, the yellow being the output curve of the single axis tracker, you get that extra power compared to the orange curve, that's a fixed tilt. In the middle there, you have shouldering. That's when it's midday. You kind of get a dip of power in the middle of the day when the tracker is flat. We have a quick video here that goes through our tracker quickly so you could understand what we're talking about throughout the presentation. So please watch this and I'll talk through it. So our tracker is based on a T design, and we do that so it allows sub-assembly in the field, but away from the foundations. So you can have a work table or assembly area that's controlled. So all our foundation connections our tracker connects from a T assembly to various foundations.
I think we lost Rob. Rob, are you there?
Yeah, that's fine. You know what, Jonathan? Let's continue through, and when we get Rob back, we'll definitely have him jump back in. So yeah, if you can let that video go a little bit, I can talk through some of that.
Okay, we'll do.
Yeah, sorry, my computer just dropped off.
Okay, well, you're back, and
yeah, so that the T assembly is the basis of our tracker, so you can sub-assemble in a more ergonomic area and reduce your labor costs by having better production in various weather events. So this is the basis of our tracker. You see our actuator here, the black unit there. It's a mechanical unit. We do offer a ballasted system, which is very good for like landfills and sites with very challenging terrain. We could connect to a helical round post. Again, you see that T assembly coming in. Driven C channel, again, different foundation types, but with the same T concept that gets assembled in a controlled area under a tent in a C can. So you have better workflow, less walking and building that T unit. And then later you put the Z channels on in the field. So most of the tracker can be built in a controlled area. Here you see the 24-volt DC motor. It attaches to the actuator itself. And then this is our flexible drive shaft that allows us to follow the terrain on challenging site conditions. This is a connection bracket that actually connects all the drive shafts within a row. We're able to accommodate various types of modules, crystalline modules, bifacial modules. We did extensive studies on what is the optimal design of our tracker to allow or utilize the benefit of a bifacial module. So we have U channels and omega beams that raise the module off the Z channel that gives you the extra light coming to the bifacial panel. We could accommodate first solar modules, series 4 and 6. So each table is independent, but the tables are attached via the drive shaft. So it allows this terrain following. So a torque tube, you would have to level the land and grade it to allow for a straight connection all the way through. Ours, the drive shaft is flexible, up to 180 panels long. And then there's no interferences between rows with any drive shafts because they run north to south along the tables. Here you can see on the right a picture of our mechanical actuator. It's a screw, and as you turn the drive shaft, it turns the gears within the unit, and then the screw goes up and down. And there's 2 or 3 per table. And then in the middle picture there, you can see our DC motor. The DC motor, you have 1 per row, and like I said, it's 180 modules long. And that actuates the entire row, and it's quite easy to turn. We've in the field turned a whole row by hand. There's such a mechanical advantage in our actuators. Ease of assembly. Here you see on the left is our T design, and this really stems from the automotive experience we have of pre-assembly, sub-assembly, reduced motion. You know, walk is waste when you're in a field and you're distributing parts and parts are laying on the ground, they're getting muddy, fasteners are being lost. Our concept when we were designing it was to make it more sub-assembly friendly, so you could control your labor costs. We all know in construction, your variable is labor, and your costs can get out of control if you're not controlling your labor. So this T assembly allows a small area to build the tracker, and like I said, under a tent in a C-can, and you can control the height, which is ergonomically better for the installers, and you can actually have better throughput and better quality control, like the torquing of the fastener, so you don't have to do it in the field. Here you could actually see this T assembly. So you can see the actuator, the extension arm, and the pivot bracket all can be built in a controlled environment. Here is a setup that we have, an assembly setup. So you bring all the parts to one area with bolts and nuts, and you could assemble the parts together and then bring them to the field rather than doing a distribution method. So it's safe for the operator because of ergonomics. It's a controlled process. You get higher productivity, better quality, less manpower, less material handling, better inventory control. And again, if it's storming out or anything like that, you could work in a controlled environment such as a tent or a C-can. Here is a increased, Jonathan, would you like to go ahead and take it on from here?
Yeah, absolutely. Thank you so much, Rob.
Oh, you're welcome.
So Jonathan Mizrachi here, Director of Sales in the US. Very excited to show you guys this product line today. I'm going to show you some more of the key benefits here while using the Axsus tracker. So right now we're showing you increased site density. Oftentimes we see sites that have challenging topography or an odd, site boundary line, something like that, where, it's just not a straight square or rectangular shaped plot of land. Our product is very nimble, very flexible because of that drive shaft design. We're able to not only adapt to these terrain conditions, but also have longer rows with one motor. So in this, you'll see a lot of consolidation of the rows, as well as an increased power density within the same site map as well. Reduced grading cost. Rob spoke a little bit about this already. So, because we have independent tables are rotated by drive shaft and not a torque tube, we're able to handle variance in topography much better. We could handle 10% grade within the table and 5% grade variation between tables as well. So a lot of times with some tough topography, we could reduce or eliminate that cut and fill, land costs significantly. Again, with the drive shaft, we're able to handle anywhere from 140 to 180 modules within the same row, all with one motor and multiple actuators. So another key benefit here with the Axsus controller is production in wind. So when the system will identify wind speeds of 30 miles per hour or more, it will go into a neutral position. Neutral position throughout the day will allow you to actually produce more energy versus the competition we see in a high stow position, where it may be set to 60 degrees, either east or west. So if you're at the wrong part of the day, let's say in a high wind environment, you're not going to produce as much energy as you would at 0 degrees. Additionally, to that point, in a high wind conditions, in 0 degree stow, we allow for the wind to pass through the modules. So low pressure on the module will reduce the risk of, micro cracks, vibration, and just overall pressure on the panels. In the high stow, which you can see on the right side of the screen with the competition, you're going to have that brunt force of the wind fall directly upon the face of the panel, creating a higher pressure on those modules. So foundation compatibility is something that we speak about a lot. Polar racking with our fixed tilt product has always come with the idea and mindset and business plan to come up with solutions that fit the actual project needs. So, we like to look at the geotech reports, see what the soil conditions may be, and actually choose the right foundation to the site. So not trying to put a square peg in a round hole type of idea. With that, we have multiple foundations that we could use with the Sol-X tracker as well. And here we're just giving you some examples of driven C-channel, driven I-beam, driven round post. We're able to do helical or ground screw. And then, of course, another hot topic is ballast on the tracker, which is really great for landfills and some tougher topographies as well. So with that, I'm going to hand it over to Dikran Ghorghorian, our Director of Engineering.
Hi, everybody. Again, my name is Dikran, and I'm going to go through the design and specification of the Sol-X 20 and 25. The tracker technology, we have, as our colleagues have said, like individual tables, they are all connected with a drive shaft, a flexible drive shaft, and they independently drive. So any terrain you have, you can have up and down with 10% plus, 10% minus on grade between tables, plus or minus plus 5 degrees. Our tables, a row length basically will be consist of 180 modules. 180 modules, if you have your module size about 2 meter by 1 meter, nowadays we have even bigger 650 watt or a little bit larger modules. With that, you can have anywhere from 140 modules per row we can have. And in different than competition cannot go more than 90 because of stability issues that they may get. But ours is like we do not have that because each of the piles have actuators rigidly mounted on it, and it doesn't let the table fluctuate. Table length, again, we have two types of tables, 12 and 24. 12 is in exterior tables and 24s are interior tables. And I will go through that in the coming slides in terms of what the differences are between those two. Drive unit, we have tested the drive unit for 30 years and more. In like my background again is automotive, and in automotive you can't just ignore environment, you can't ignore temperature, dust, freezing rain, all of this stuff you cannot ignore. So, and also the loads, what type of loads is going to see during its lifetime, and what are the up and downs. So we have done extensive study in the back, and we have come up with a methodology of testing, and we tested it like the drive shaft, for example, we tested it for 40 years, and we stopped the test at the end. The train following, we talked about it. It will go up and down. Wind speed design. Currently, our tables are more or less, because that's the request we get more or less from all customers, around like 90 to 110 miles per hour winds. But we can design it to a higher wind speeds or lower wind speeds, depending what the customer requirement is. Rotational range is 120 degrees, plus or minus 60 from horizontal position. Ground coverage, again, typically we have it as from 0.25 to 0.65, but again, we can design it the way the customer requirement is. I mean, more you spread the tables from each other, you would get that, like we have done wind tunnel tests, and from wind tunnel, we know when you will have a certain distance between the rows, now the rows starts turning to an exterior row. So you have to maintain those things to be more efficient in the field. System voltage, 1000 volts to 1500 volts. Module attachment, UL2703, we made that with the clamps and everything. Controller, we have two controller options, self-power and an AC power. Of course, it depends, the controller selection also depends from the environment. In two cold places, we do not recommend to go with the self-powered, and we go with AC. Tracking method, time and location-based algorithm with backtracking. And remote communication, we have that remote communication set up, and we also have a SCADA solution available. And motor type, it's 24-volt DC motor that we use. Next slide, please. Now, X20, when we say X20, X25, I just want to make that clear in terms of X20 is maximum 12 module table. And these are used for exterior use, exterior boundary of the of the field. And the reason is because they do have two posts, so the span between the piles are fairly closer in terms of our X25 design, and they are stronger, much stronger than the interior ones. And because that's what will take all the wind and everything. So we maximize it to 90 modules per row for exterior rows. And for interiors, we have 180 modules, and which have a controller and a motor. Can you go back? All our material that we use for bracketry and roll forming are 50 or 70 grade material. We coat all our basically fasteners are class 8.8, and torque is per AISC steel construction manual, and all of these tables again follow within table 10 grade and between table 5 grade requirement. Our leading edge can vary from 600 to 1.2 meter. 1.2 meter, and we can make it, this is our standard design basically, but if you would want to go higher or lower, we can accommodate that for you. Next slide, please. And this is the X25. X25 is kind of take it as two X20s attached together and removing one pile, moving it to the center. It's like to join the tables, I guess we're using some splices and stuff, and then as you can see in the box in the bottom that we have connected thoroughly together. And all these are joined with the flexible shaft that you see the wire underneath that it goes, and that basically joined with couplers together. It's all standard size. As long as we can get the standard size, one size drive shafts that you just put it in series and connect them. Next slide, please. This is a close view of the actuator and motor assembly. Now, remember, motor goes only on one of the actuators on the middle table of the row. Not every actuator has a motor. It just goes through on the middle of the table of the row on one of the actuators, and it does the job of rotating the whole 180 modules. And as you can see, it goes through the motor gearbox, it goes through the actuator gearbox, and comes out from the other end and continues. And once you get to the end, tip to tip of those drive shaft, you have a coupler that connects them together. And next slide, please. And the controller. Jonathan mentioned about the 30 miles an hour that we go to horizontal position, but we also have another stage. When you have a 20 mile an hour wind, it will limit your tracking to plus or minus 45 degrees, so that you can get the most out of what you can get through that wind, basically. But once it exceeds 30 miles an hour, we go to stow position, which is at 0 degree. Product validation, we have done so much testing on these parts. I mean, every connection, we have done strength tests, we have done any moving components that move against each other. We have done like durability tests to make sure that we do not have any wear, tear. We've done like afterwards, like after the test, we disassembled everything, checked every single part to see any marks of wear or tear. So I think it's a fairly robust system that we have. Next slide, please. These are some of the pictures that I show from our testing. Like the first one, for example, is a drive shaft durability. All the wires go to the resistors at the end. These are provides resistance as if how much the line provides resistance to the dry shaft. And they will rotate one direction, the other direction, and this test goes for like 6-month period to mimic the 40 years. It is an accelerated test, and it mimics like the 40-year testing. Pivots, since we have the whole table is connected on a pins, basically, we just wanted to make sure that those pins do not wear and create any looseness. So we basically tested it on and off for 40 years again, and no wear or tear. Motor durability, again, we put resistance, cold temperature, hot temperature, ambient temperature, different loads, and we tested. Same with the actuator durability. And also we did like some rain test and dust test. This is coming, the specifications, we got these from automotive, from latches that I was in for a long time. So what you do basically is you cover the places where you had booth and everything that water could not come in, and you would check if every other place, every other crack that you may have on this gearbox, you can have any leaks inside. So with the dust test, you would put it in a dust chamber. Again, this is automotive kind of test we do, and it will blow all dust, very, very tiny Arizona dust, and we'll see like if it's going to go in the actuator after you disassemble and you check for any dust intrusion. Next one, please. These are all the strength tests that we've done. Like, as you can see, the pivot arm in the front, we've done like full tensiles, then motor infrared. The reason why we did the motor infrared test is just to monitor the heating of the motor in normal function and also in accelerated function, because we were going to do an accelerated test, and we just wanted to mimic exactly what it sees on the field when it rotates and stops and rotates and stops, because every time that it rotates, basically from combinator to the brush, you can get a spark, and that will start heating up your motor, and you just monitor to see like what the temperatures are here, there, and accordingly mimic the same thing on a test. Pivot arm, spherical bearing, again, it's not only durability we did on the spherical bearing, but also tensile tests. We do full-scale tests by putting loads on one side of the table or on both sides of the table to mimic the full loads, and measure deflections of the purlins to see if it meets or if it's equal to what we had calculated. For us to get that confidence, designing something in the future, we will be that sure that it is going to reflect what it's going to be in actual environment. And as you can see, actuator freeze, that actuator is completely basically under frost, and we check for functionality. Inner clamps, outer clamps, tensile, we do also, just to make sure that the clamps we're using are proper. The next slide, please. I'll hand it over to Jonathan now. Jonathan, please.
Yeah, thank you, Dikran. So coming to the end of the presentation here, but yeah, we would like to show, so we actually have a little over 100 megawatts of already installed sites, both in Canada and in the US. In the US, mostly in upstate New York. There's about 15 sites in upstate New York that have either been built or are being built currently this year. So lots of deployment happening and growing market share, and excited to have this new and very different product line in with the Polar team. So just to reiterate some of the key benefits here that we spoke about today on the presentation. One is easy assembly. There's no heavy equipment or specialized equipment needed on site for assembly. Again, we use a drive shaft, very different from a torque tube. You don't need a lull or again, heavy equipment to lift and hold in place. Really all you need on site is two field workers that are able to lift those tees and then place them, where they need to be on top of foundations. Adaptable table lengths. Again, we showed you a little bit about this with topography and site layout. So more flexible design, able to fit more panels in any given area, increasing power density, DC density. Terrain following capabilities, we spoke about 10% grade within tables and 5% in between tables. So this allows us to, again, reduce the need for cut and fill or any grading on site. Higher production during windy days. Again, we stow at a 0 degree. Once it hits 30-mile-per-hour winds, we stow at 0 degree, allowing us to produce throughout the day if you are in a windy climate. Pile to racking connections, multiple pile to racking connections, so we're able to handle all the major types of foundations, being I-beam, driven C-channel, round post, helical, ground screw, and even ballast. All lightweight components, allows us to ship a little bit more densely, handling in the field much easier. Again, increasing your production in the field, increasing your optimization of the project. And of course, what Dikran just spoke about, extensive testing. Coming from automotive, our product has been tested extensively in multiple conditions through heat, cold, rain, dust, and of course the longevity of time. So we know it's a durable product, gonna last the test of time. Owners will love this product with the durability that we set forth. So with that, I'd like to open it up to some questions, Q&A section, and let's see what we have here. So first question was from Greg. Will northern latitudes, example, 56-degree north latitude, show as much benefit from an east-west tracking compared to southern latitudes? Rob or
Yeah, correct. As you go north, there is less benefit to the east-west tracking. And of course, in the south at the equator, you have the most benefit with the sun directly above and the tracker and the sun going east to west. So yeah, as you go north, the benefit of the tracker goes down. And you can evaluate that on your site per your PV-SYST analysis to see whether it still makes sense to go to a fixed tilt or a tracker in that case.
All right, another question here from Greg. Do all motors activate T once or are they individual? What is the maximum sound rating?
Yeah, we can, and that's a good question because a lot of times that affects your cable sizing. You don't want to draw in the sizing of your system in general for powering the motor. So yeah, we can delay activation of rows so that you're not drawing as much current, so you could use a smaller cable gauge. Decimal, very quiet. I guess I imagine in terms of sound was the question. Very quiet system. You can't really hear it operating. Most of your noise will be coming from your inverters on site.
Next question is from Young. Backside shading impact on bifacial module when comparing with tracker using single torque tube.
Yeah, so what we did was, and we knew bifacials were the new thing coming, and years back we did a ray tracing analysis and we looked at basically we took the bifacial panel and simulated it without a structure and how much performance you got without a structure. And then we added and redesigned our structure so that we maintain the benefit as much as possible of the bifacial panel. So our design elevates the bifacial panel to allow light. So we elevate the panel off the Z-purlin, which is nearly the same performance as a panel itself without a structure.
Great. Next question is from Adam. Do you have data on increased kWh to kW for sites in Canada, perhaps ranging from southern to northern latitudes?
Similar to the earlier question, we would have to look at it on a per case basis. There's a lot of variables on site, so if you'd have to look at the topography, whether it's north or south facing slope, a south facing slope plus the latitude, and then we'd have to again look at a per cases basis.
Great. Next question is coming in from Matthew. Current minimum, maximum order volume. Great question, Matthew.
There's no max. I'll make that half easy. Minimum, I think right now where we look as low as 1 megawatt. The sweet spot for us is like, most of our projects to date are the community solar projects that we're doing right now, which we're doing, dozens of. Those projects range between 5 and 10 megawatts. So that's really our sweet spot. But, 1 megawatt for sure, half a megawatt, if it was, part of our portfolio is something we'd look at. But yeah, generally like 1 megawatt plus is where we're at.
Great, thank you, Vishal. Jesse is asking, what is the distance from point of rotation to the driveline mounting height? That's his first question.
Point of rotation, meaning the drive shaft to the pivot point.
What is the distance from the point of rotation to the driveline mounting height? Yes, from the pivot.
Yeah, that's a drive shaft. Drive shaft to the pivot point. It's about about 900 millimeters.
And the second question, what are the maximum heights at which you can support wind loads?
Sorry, can you repeat that again, please?
What are the maximum heights at which you can support wind loads?
Maximum height. I mean, again, maximum height, we got it as 1.2 as this point, as a system height. And we can actually design further higher. But again, we have to make it will come a little bit outside of our standard. And we have to design the post and everything accordingly, and the members accordingly. And we do have everything set up. It's just a matter of what the customer requirement is, and we'll design it to that.
Great, thank you, Dikran. Greg posting another question. Rough cost comparison to usual fixed ground mount rack system, materials, and install costs. So I guess what is the comparison between costs on a fixed ground mount and a tracker based system that we're showing here today?
Yeah, that's a good question, and that has changed rapidly with the increased steel costs. So there was a larger differential between fixed and tracker, and through improvements in tracker designs, it came down, but there was a differential. But with the steel going up, there's less steel in a tracker than a fixed tilt, because you have to account for more snow loading on a fixed tilt. So right now we're seeing a comparable cost of a tracker system, just the mechanical components, no electrical wiring or anything, but the mechanical components of a tracker compared to a fixed tilt are about the same. And material install costs, I would say, relatively the same. There is a little bit of extra wiring for the tracker, but in general, they're at par with each other now. And that's more due to high commodity prices of steel.
Great. Thank you, Rob. Next question comes from Red. Do you have plans for 2-panel design and portrait with bifacial?
Yes, we do. We do have the design. We're actually in the process of validating it right now. But yes, we do have the design, and we have actually even built the sample.
So coming soon.
And
Coming soon, yeah.
And it would be in portrait.
Yep. What's the timeline approximate, you think?
Next year at this time, I would think.
Next year around the same time.
Yeah.
Great. All right. Another question from Yang Yang. How many piles per exterior row? 90 modules, and how many interior?
Well, you have how many tables? You have maybe like 9 tables. Maybe you have 8 to 9 tables per row, and that will make it about 18 piles basically per row. And
Dikran, it sounds like you're cutting out a little bit.
no, I mean that's the answer. A row is basically like an exterior row is like about 9 tables, each table having like about 12 modules.
Yeah. And
you would have 9 tables times 2 because each table has 2 piles. That's 18 piles, if that's the question. 18 piles per row.
For an exterior and for an interior?
For an interior, it cuts down because now you have
About
90
Yeah, now you're
modules.
going to X25.
yes.
Yeah.
You're looking at 22 piles per interior row with 180 modules. So it's 180 modules to 22 piles.
Yeah, so if you have like 8 tables on an exterior, you're looking about
But
I think on the exterior, if you have 180 modules, because we've been doing 150 and 180, you'll have a little bit more on the exterior and a little bit less on the interior, right? So
okay,
Correct.
thank you guys. Red has another question. What is the warranty on the tracker?
The warranty is broken up in, like all tracker companies, it's broken up into structural. So 20-year structural, 10-year for like any electronics, and 5-year for motors.
Great, thank you, Rob.
The maintenance schedule, there isn't anything to grease or anything. So the question is, sorry, what is the maintenance schedule? It's typical. It's just a yearly inspection. We're looking for basically a sample size of checking torque on bolts and things like that. And if there's any issues, which means it was probably done in installation, then you expand your sample size. But it's a yearly inspection of basically if there's any corrosion, looking for anything that's corroded on site, torqued bolts, and then if there's any issues, you expand your maintenance program. But there isn't any greasing or anything like that. Everything's self-lubricating with the actuators.
I would say, Greg, it sounds like you have a project in mind based on your question. So if you just want to contact us happy to, get you a layout, get you a proposal, get you, the install manual, and we have a pretty detailed maintenance manual as well. That's part of that, and run through it with you on your specific project for sure. And all great questions, by the way.
Another question coming in from Jake. Plans for US-based manufacturing, and then second question, what's the hail strategy?
So nice to hear from you, Jake. Jake, we worked together in the past. Yes, we do look at manufacturing in Canada, US, and overseas. So we're implementing different manufacturing strategies based on demand, of course. Hail strategy, we're working on a hail strategy as we speak, so we'll release that as well. Are there any more questions or?
Some pretty good questions out there.
Some tough ones.
Yeah. Give it another couple seconds if anyone wants to enter in any other questions. If not, I guess we could start wrapping it up.
Yeah, for sure. So yeah, I mean, I'd like to thank everyone that attended. Really appreciate it. Thank you very much, John, Dikran, Rob, Janet, and Michelle, who are behind the scenes. Thank you very, very much for all your help. For those of you that are interested, obviously we are here to take your questions and work on the projects with you. Please email sales@polarracking.com. We'll get you to the right person that takes care of your area, whether you be in the US and Canada or the Caribbean. And yeah, we'll start from there, and we'll get you everything you need. Obviously, this a recording of this presentation will be sent to you guys now that we have you registered for the webinar, and we have your contact information, as well as it'll be up on our YouTube channel here within a week. And at any time you can visit our website for more information, including that video that Rob went over at the beginning of the presentation, in case you want to see some more detail on the tracker itself. So
yeah, the video is right on our website, so feel free to take a look at our website at polarracking.com and able to click around. We have some good info and material up there, as well as the video.
For sure.
Great. Thank you, everyone.
Thank you, guys.
Thank you, everyone.
Thank you.